In our last video, we were talking about the savings plan formula. The savings plan formula is written right here. It's A is payment times 1 plus R over N to the NT minus 1, all divided by R over N. And we use this formula when we have monthly payments. If we know the monthly payments, we know the rate, and we know the time, we'll be able to figure out how much money is in a bank after a certain amount of time with a certain amount of payment. Over here I've written two formulas, and these formulas are the same as this one but solved for payment, because we're going to look at problems where we are told how much money we want in the bank after a certain amount of time, and we're going to be asked how much money do we need to put in every month. So here are the two formulas. You can use whichever one you like. It doesn't matter which one. Just notice that and this one is all multiplication, but the last thing is raised to the negative 1 power. And in this equation, this formula, we have a division sign. So let's look at our first problem. Your goal is to create a college fund for your child. Suppose you find a fund that offers an APR of 5%. How much should you deposit monthly to accumulate $85,000 in 15 years? Okay, let's write down the key information. First, I know I have an APR of 5%. So let's say R is 0.05. I know that I want to accumulate $85,000. So that's how much money I want in the bank. So A is $85,000. I also know that T is 15 for 15 years. Remember, T is always in years. So the important part here, and this will help you figure out which equation you're going to use, because remember there's several equations. There's the compound interest formula, and we solved the compound interest formula for P, and we had the compounded continuously, and we solved for P, and you're going to have to figure out which formula do I need to use. And the key to doing that is to look at what it says. This one says deposit monthly. The other formulas, the compound interest formula and the compounded continuously formula and the simple interest formula, all of those were when you were putting in money one time. You weren't adding any more money to your savings account. When you're depositing monthly, you're making a savings plan, and that's how you know you're going to need to use either this formula or this one here. So we're depositing monthly. And our goal is to figure out how much money we should put in. How much should you deposit monthly? So we're trying to figure out our payment. Okay, so that means if we want to solve for payment, we need to use one of these. Now, which one you use, it doesn't matter. I'll do both for this example, and then you can just choose which one you like. So let's start with this one. So payment is $85,000 times our rate, which is 0.05, divided by N. Now remember what I said in the last video. N with the savings plan formula is always going to be 12. Okay? Don't forget that. So we're putting a 12 here. 1 plus 0.05 divided by 12, raised to the 12 times 15. That's not a 5, it's a 15. Because the problem said 15 years. Subtract 1, raised to the negative 1. Let's put that in our calculator. So I'm going to try to put it in just like I see it. 85,000 Now, I think I mentioned this in the last video, but these are just fancy parentheses, so you can tell the difference between the different parentheses. We only have one type of parentheses in this calculator, so I'm just going to double that up. Okay. Look at everything I've written down. I have 85,000. Am I missing something? I think I'm missing something, aren't I? I put all of this stuff here, but I didn't put this. So let's go back. I could add it to the end, but I want to stay consistent with this problem. So 0.05 divided by 12. 1 plus 0.05 divided by 12. 12 times 15, subtract 1, raised to the negative 1. All right, now let's double check. 85,000, that's right here. 0.05 divided by 12 in parentheses, that's right here. I have a parentheses there, and another one right here. 1 plus 0.05 divided by 12, close parentheses. Make sure you put this in parentheses at the top. 12 times 15. Okay, close that parentheses to end it. That's very important too, that you put a parentheses here. Subtract 1, and then I want this fraction, this piece right here, raised to the negative 1. Now we're going to hit enter. And we get 318, we're going to round to the nearest cent, so the nearest hundredth, 0.01. I'm going to circle it, and now let's talk about it. This amount of money is the amount that you want to put into the bank every single month for 15 years to reach this goal of $85,000. Now let's try the other formula just so that you see that I can use either formula here. Another thing I mentioned, I might have mentioned it in the last video when we were, maybe I did. Yeah, I did. I told you that maybe you should do just the top part of the fraction and then hit enter and then divide by the bottom part. That's what I'm going to do with this one here. And also you can do it here too. You could just do this and multiply this part, and then when you hit enter, multiply it by this. And the only reason I'm suggesting that is so you don't have a lot of stuff that you're writing in the calculator. You can break it into parts. You could say a times this, and then hit enter, and then multiply by this. Okay, let's try it the other way. So I'm going to erase this. Now I'm going to write it over here. Using this formula, we got 318.01. Let's see if we get it with the other formula. Okay, now we're using this one. So I'm going to write everything down. 85,000, 0.05 divided by 12, divided by 1 plus 0.05 divided by 12, raised to the 12 times 15 minus 1. So it's basically the same thing. The only difference was what we had written here is now in the denominator. Let's put it in our calculator. So we have 85,000 times 0.05 divided by 12. So here's the whole thing. And I'm just going to do the first part. So 85,000 times 0.05 divided by 12, hit enter. Now we're going to take that and hit divide. And then in parentheses, we're going to write this. 1 plus 0.05 divided by 12 raised to the 12 times 15 minus 1. Double check you have everything. We already did this part here. So divided by 1 plus 0.05 divided by 12 raised to the 12 times 15, subtract 1. We got the same answer, which is good. We should always get the same answer. 318.01. Okay, let's try another one. So I think we have a total of 3 problems we're going to do. Let's switch colors. Let's go with red. At age 20, when you graduate, I guess graduate from high school, or I guess you could graduate from college at 20, or I think a little old for high school. So at age 20, when you graduate, you start saving for retirement. If your investment plan pays an APR of 4.5% and you want to have $5 million when you retire at 45 years, how much should you deposit monthly? Okay, deposit monthly. That means we need a payment plan and we need to solve for payment. So let's write the payment formula. You pick the one you like. I think I like the bottom one better, so that's what I'm going to use. Okay. So we want to know how much we should deposit monthly. So that means, what is payment? What are the pieces we know? We know that we have an APR of 4.5%, so our R is 0.045. Okay. We know that we want to have $5 million when we retire, so our A is 5,000,000. Okay. And we're going to retire in 45 years. Still pretty young. We'll be 65. So that will tell us the T, 45, because that's how much money we want when we retire. We want $5 million, and so we're going to have to put some money in every month for 45 years to try to get that $5 million. So how much money do you have to put in? That's the question. Okay, let's use the formula. So payment is A, 5 million. R, which is 0.045, divided by 12. Remember, N is always 12 with the savings plan formula. Divided by 1 plus 0.045 divided by 12 raised to the 12 times 45, subtract 1. And we're going to put that in the calculator. How I like to do this is I like to put the top first, just so I can break it into pieces. So 5 million times 0.045 divided by 12. Hit enter. Divide by 2 parentheses, 1 plus 0.045 divided by 12. Raised to the 12 times 45, subtract 1. Let's double check. 1 plus 0.045 divided by 12. In parentheses, I have 12 times 45. That's important. Subtract 1. Wow. $2,863. So let's write that. 2,863.70. So let's interpret this. So we have to put almost $3,000 in the bank every single month, not taking any money out. Just put it in there. This has to be extra money that you're going to put in the bank every month for 45 years. Okay, 45 years is a long time, and you've got to be making a lot of money to put about $3,000 in the bank every month. How much money would you have to be making? Let's see, $3,000. Let's do the amount we got. 2863.7 times 12. If I just put this 2863.7 and multiply it by 12, I would have to have 34,364.4. I would have to put in, this is basically an income. This is like making money every month and not taking any money out. If you made $34,364 every year, you would have to just be putting that money into the bank at this rate, $2,863 every month to make this $5 million. So most people will not be able to, if they made this kind of money, they would not be able to put every single penny into the bank. So the idea is hopefully you'll be making at least twice this, and then you'll be putting half or even more. I would hope that you would be making more money, so you could afford to put about $3,000 in the bank every month. But yeah, so that's a lot of money. And so $5 million is a lot of money too. So if you want to make this kind of money, you want to have that in the bank, you're going to have to be putting a lot of money into the bank if it's for 45 years. And 45 years is a long time with this APR. I'm just curious, how much money do we actually put in the bank? So we're doing this for 45 years. So we're putting this amount for every month for 45 years. So let's take this and multiply by 45. Okay, so if we have this and we multiply it by 45, we'll get 1,546,398. Okay, so this is actually a pretty good return on our money, because this is how much money we actually put in the bank, about $1.5 million. So we're almost, I would say, tripling our money here, because if we triple it, it's about 4,500,000. Yeah, I mean, that's a pretty good return. So we're putting a lot of money in, and if you want to get a lot of money out, you have to put a lot of money in. So we're putting a lot in and we're getting a lot out. But I don't really think that this is feasible. Most people can't put that kind of money into the bank. So if you want to retire with a lot of money, you're going to have to think smaller, maybe put $1 million here instead and see how much money you have to get out. Or you have to have a really good job.